Here is a little recap of covariance metrics. Covariance metric is an n-dimensional n-by-n matrix containing the covariance values for all pairs of features in a dataset with n features. Simply put, covariance matrix में हम क्या कर रहे थे? Given any two variables x and y, we were looking for the relationship between them. So if any change in x determines change in y, we need to, or we want to measure the type of change, if this is directly proportional or inversely proportional. And then secondly, we'd like to measure the intensity of it. So how is it highly proportional or less than that? The diagonal contains the covariances of features with itself, which is usually known as variance, or simply variance is the spread of the data. And when we have two variables, this is known as covariance. So variance is the covariance of one variable with another. So variance is simply one variable's own spread, whereas covariance is the relationship between two of these. The matrix is the metric. So this is the, since we'll be using a covariance matrix, so it was important that we discussed it before moving forward. Mathematically, we can give as variance is the difference of the value from its own mean. That would give us the spread of any variable. And since we are calculating variance, we do this twice. So we have the square of these. And in covariance, we measure the spread of one variable x with respect to the other variable y. So these are the mathematical definitions of both of these. We have covered in class. We have done these before as well. So I hope you remember these pretty well by now. In covariance, you're more concerned with the sign rather than the exact value. The sign tells you whether these are positively related or directly proportional or inversely proportional. So positive value means that increase in one feature increases or decreases the other also. And similarly, negative means that increases in one decreases the other. So it's an opposite relation to one another. And the value close to zero, anything very close to zero would suggest that the variables are independent of one another.